Carbon footprint is actually an analytical calculation of the impact of a material on its environment. And so in the coatings industry, you hear a lot about environmentally friendly coatings, eco-conscious coatings. There's water-based coatings, powder coatings, low VOC. Life cycle and carbon footprint analysis is a way to actually measure the impact of these coatings and materials on the environment. And it's a way to actually get numerical values that can be compared across different types of coating technologies. In the architectural market today for fluorinated coating systems, and so these are systems where you need a very long life cycle and performance. The PVDF system is typically a solvent-based system, and the FEVE type system is what's called a powder coating. And so when you compare the carbon footprint of both of these types of systems, you'll find that the solvent-based PVDF does have a higher life cycle cost and a carbon footprint because it has organic solvents. That's a huge driver of the impact to the environment. And with powder coatings and FEVE powder, you eliminate the need for that organic solvent. So that's a very big impact on reducing the overall carbon footprint of the coating system. FEVE powder coatings also cure at lower temperatures than PVDF solvent systems, and that also has an impact, reduces the impact of the carbon footprint. And finally, with powder coatings, you have the ability to reclaim the powder. So when you're spraying and applying the powder to a part, any of those powder particles that do not get onto the part, you can actually reclaim those and reuse those. So the transfer efficiency of powder is much higher than traditional solvent-based systems. And so all those things, the lack of organic solvents, the lower oven cure temperatures, and also the reclaimability or recyclability are all things that can impact and reduce that overall carbon footprint of the coating system. With fluorinated coating systems, you have systems that have very long weatherability and durability outside, and so they're often used on exterior architectural applications. Think of window frames, you can think of curtain walls, sunshades, louvers. And so with powder coatings in particular, you're often using electrostatic spray in the factory, and that electrostatic spray is it takes the particles of the powder and there's a charge that's created at the spray gun nozzle, and that is attracted to the part, which is actually grounded. And it's interesting to note that oftentimes when people think of electrostatic spray, they assume that you have to apply these coatings to metal parts. And actually, that's not the case. Because again, the charge is at the gun and with the particles themselves. So the part just needs to be grounded. So powder coatings are not just used on metal, they can be used on wood, MDF type furniture. Powder coating is very widely used even outside of architectural, but in the architectural space today, they're used primarily on factory applied windows, curtain wall units, and as I mentioned, some of the ornamental type metal features like the sunshades, the louvers, railings as well. While calculating carbon footprint is an analytical method and uses numerical data, there can be wide variation in the calculation based on the variables that are used as what we would call inputs. So in this particular carbon footprint analysis, we looked at two different coating technologies, the FEVE powder and the liquid PVDF system. And within those two technologies, we actually looked at two different coating conditions. We also made some assumptions. Again, these are those inputs that carbon footprint analysis has. And so with the FEVE powder, we assumed overspray was recycled. And so transfer efficiency in one of the conditions was at 90%, and at a second condition it was at 70%. Whereas with the PVDF liquid system, again, these are solvent-based systems. The overspray cannot actually be collected and reused. So the transfer efficiency is lower. And so we assumed in one system 20% and the other 40%. And so when you also discuss carbon footprint analysis, you have to think about all the materials that are used, not just in the paint itself, but in the making of those raw materials that go into the paint. So the data on the raw materials in this study, including the transportation impact, the packaging material impact, and the waste impact, all come from what's called the Product Environmental Footprint Catalog Rules. So that's the PEFCR, and this actually has numerical values for different raw materials that are used in paint systems. So those, again, are some inputs that were included in this calculation. The results of this carbon footprint analysis are shown, and you can see that when you look at the FEVE systems, again, these are those powder coating systems, compared to the PVDF systems, you see a big difference between the actual carbon dioxide output, and of course the calculation presents it as weight of carbon dioxide per area. In this case, it's kilograms of carbon dioxide per meter squared. So again, this is the output or the impact, the carbon footprint of utilizing these coating systems to, say, coat extrusions for a curtain wall. And so you can see in this chart here that with the FEVE powder systems, in both cases, one at the 70% transfer efficiency and then one at the 90% transfer efficiency, you have a significantly reduced carbon footprint than you see with the PVDF solvent system. The primary driver is the actual use of the solvent with the PVDF system. So that organic solvent has to, it's used and then it evaporates into the environment and or it's incinerated. And both of those processes lead to an increase in carbon dioxide into the atmosphere. And so with these different coating systems, regardless of the transfer efficiency of the FEVE powder, you ultimately have lower impact to the environment with carbon emissions. And what this means in a real world application is, for example, on a 100,000 square foot project, again, we're talking about area here, you can have a reduction of up to 16 tons of carbon dioxide into the atmosphere used with the FEVE powder system. It has a reduction of anywhere from 23 to 46% of a reduced carbon footprint than the solvent-based PVDF systems.